See students, as we saw into Bayes process, sodium hydroxide is taken for leaching. In Hall's process, sodium carbonate, that is Na2CO3, will be taken for leaching. So as I've taught you before, that into the process of leaching, the desired agent will only be soluble and rest of the things are not going to be soluble. The impurities or other compounds which are not which are undesirable, which are irrelevant, these are not going to be soluble into that. So here into a digester, sodium carbonate will be taken along with the powder ore. It will be heated and then it will result into formation of water soluble sodium aluminate. Then the insoluble impurities will be formed as a residue, and this can be filtered out, and whatever filtrate will be obtained, that will be warmed. It will be neutralized by passing carbon dioxide, and this will result into formation of aluminium hydroxide as a precipitate. So I have taught you precipitate, that it is an insoluble solid into a liquid medium. So here the precipitate is going to be aluminium hydroxide, which has been formed by warming or by heating the filtrate and by neutralizing it by passing carbon dioxide gas through it, and the reactions are going to be somewhat like this. So this was alumina, Al2O3 twice H2O. This was reacted with Na2CO3 into the Bayes process. So it was soluble, this alumina was soluble into Na2CO3. It formed sodium aluminate, that is NaAlO2, then carbon dioxide gas and water. Then this sodium aluminate was neutralized by passing carbon dioxide gas, and it resulted into formation of aluminium hydroxide, AlOH thrice, and this is going to be a precipitate, and that is why it is shown by a downward arrow like this, and byproduct is going to be sodium carbonate again. Then the precipitate of aluminium hydroxide will be obtained both in Bayes process and Hall's process, but what we want is aluminium. So here this aluminium hydroxide, it will be washed, it will be dried, and it will be heated into the absence of air or into limited supply of air at 1000 degrees Celsius, and this process will be known as calcination. And when this thing will happen, from aluminium hydroxide we will get aluminium oxide, that is alumina. So this is how we will obtain alumina. Now we have to reduce we have to do the reduction of this aluminium oxide so that we will get aluminium. So see, this is the entire setup of electrolytic reduction of alumina. So alumina will be taken, or this aluminium oxide will be taken into this tank, and this the steel tank will be having a lining of graphite, and this lining will act as a cathode, that is a negative electrode, while this anode, these electrodes are going to be made up of graphite again, and these are going to be act as an anode. So at anode oxidation will take place, at cathode reduction will take place. Then see what will happen in this method. Electrolysis of molten mixture of alumina means aluminium oxide, that will be done at 2000 degrees Celsius, and what will happen over here is that we have to add cryolite, that is Na3AlF6, and fluorspar, that is calcium fluoride, will be also added into the mixture so that the melting point will be lower, up to 1000 degrees Celsius, because it melts at a very high temperature. So to lower the temperature, to lower the melting point, this cryolite will be added, and this fluorspar will also be added in order to make that mixture quite bulky, and because of that the aluminium will become heavy and it will be sink down at the bottom so that it can be easily removed out from this outlet. Now this aluminium will be deposited on the cathode by passing the electric current, and then molten aluminium, as it is going to be heavier than the electrolyte, it will be collected from this outlet over here. So it will be settling down due to the force of gravity, and then oxygen gas will be liberated here at the anode. So see, this kind of reactions will take place, as anode is an oxidation electrode, oxygen gas will be liberated over here, and at cathode reduction will take place. This aluminium ions will gain 3 electrons and will form aluminium metal. So this is how by all these processes we can finally obtain aluminium, and the liberated oxygen will react with anode to form carbon dioxide gas, because anode is made up of graphite and graphite is an allotrope of carbon. That means oxygen is combining with carbon over here for forming carbon dioxide gas, and because of this the anodes are going to be changed every time to time, because there will be formation of carbon dioxide gas because of the oxidation of this graphite electrode. So this was how the reactive metals we can extract, and rest of the things we shall learn into next video. Till then, have a knowledgeable day. Thank you.